We have two cases. One case we have voltage source and the switch will be open at t is greater than equal to 0. In this case, when the switch is open, the voltage stored in the capacitor will be dissipated on the resistor. And as we can see, this one, this is the current, this is the current moving outward. So we can have the equation that we have C dV by dt. This is the current capacitor current, plus we have VR divided by R equal to 0. Similarly, the same equation we can use here, the same equation, but this time if we talk about the resistor voltage, so the C dV by dt will be same, but the resistor voltage will be, because the and tail is on the upper side, so we can say that this is the V initial voltage of the capacitor. We have V, and then we have Vs. You can say this is voltage of the capacitor. So to make it easy, this is the voltage of the capacitor, Vc minus Vs divided by R equal to 0. So we can say that dVc divided by dt equal to Vc divided by Rc equal to Vs divided by Rc. So if we see, divide, open this one, and we divide by C, so this C will divide by everybody, so this becomes dVc divided by dt plus Vc divided by Rc minus Vs divided by Rc. And if we move Vs divided by Rc on the right hand side, so this becomes this equation. So Vc dVc divided by dt plus Vc over Rc equal to Vs Rc, because we are moving from the left side to right side, so this becomes plus. So here we can also say that dVc dt equal to minus Vc over Rc plus Vs over Rc. And if we take the Rc as a common LCM, so we have Rc and we have Vc minus Vs dVc divided by dt, and then we can say dVc divided by Vc minus Vs equal to minus 1 over Rc dt. If we take an integral on both sides, integral on both side, we can have, and we take an integral, so initial voltage is V naught and the final voltage will be V of, depend on time. So dVc over Vc minus Vs equal to integral initial t naught to t, and we have minus 1 over Rc constant and dt. So as we know that the when we have the function and 1 upon x, so it becomes 1 ln x of integral. So we have that integration of dVc by Vc minus Vs is will be the ln Vc minus Vs, and the limit will be V naught to V of t. Then we, on the right side, as we know, the dt, integral of dt is only a t, so we have t naught and t. If we implement this one, so we can say this ln V of t minus Vs minus ln V naught minus Vs equal to minus 1 over Rc T naught minus T. And if we assume that T naught equal to 0, so this will becomes negligible. So we on for this one, when we implement the integral, so it becomes T minus T naught. Okay, as we know the property of ln, when ln a minus ln b will be equal to ln a divided by b. So we can also write here, we can also write ln v of t minus vs divided by v naught minus vs equal to minus 1 over rc, and we assume that the t naught is equal, t naught is 0, so just a into t. So to remove the ln, we need to take exponential on both sides. So taking exponential on both sides, so we have v minus we have v of t minus vs divided by v naught minus vs equal to e power minus t over rc. As we discussed, this is the tau, and we know that tau is equals to rc. So we can say that v of t minus vs is equals to v naught into v minus vs e की power minus t over rc, and vs if we move here, so v of t equal to vs plus v naught minus vs e की power minus t over rc. So when we have a force response, so we will consider this scenario, and when we have the charging mechanisms, which you can say natural response from the capacitor, so we will use the equation as we discussed last time, which is v of t equal to v naught e की power minus t over tau. So this is basically, this equation is a force response, and if we have equation v of t is equals to v naught e minus t over rc, and this equation is a natural response when the capacitor discharge its energy and the resistor dissipate that energy. So this is the natural response. Let's take an example. Plus minus 4 kilo ohm, 0.5 millifarad. This is 30 volts. This is 24 volts. This is 3 kilo ohms, and if we have 5 kilo ohms, and we say that at t equal to 0 or greater than 0, the switch moves from here to here. This switch moves from here to here at t greater than equal to 0. When t greater than equal to 0, so initially at t is equals to initial case, what is the initial voltage just before 0? So we just write, let's suppose that just before 0, we can say just before 0 we have the voltage. We need to, as we know that the capacitor is open in DC circuit, and the initially what the assumption is that capacitor is fully charged, and this is the open condition. So the voltage across the capacitor will be 3 kilo ohms and 5 kilo ohms. These are two resistors, so the voltage across 5 kilo ohm resistor will be the voltage across the capacitor. So we can say that we have 5 kilo ohm resistor, plus 3 kilo ohms multiply by 24 volts will be 15 volts. This is the initial case. So less than 0, before less than time less than 0, we have the voltage across the capacitor is 15 volts across 0.5 millifarad. So what is the value of tau across the when we talk about the capacitor? We just make a tau calculations. Okay, we have 15 volts. Now what we now if you want to calculate the capacitor value when the time is equal to 0 or greater than 0, we can say, what is the equation? The response of the capacitor, the force response of the capacitor will be the voltage source, the time infinite voltage source, because after 0 second, it will till infinity this voltage source will work. Will work. The general equation is Vs plus V naught initial voltage minus Vs into E minus T over RC. As we know that Vs, the new Vs is the 30 volt, and V naught is the initial voltage, which is 15 volts. So we can write 30 plus 15 minus 30 E minus T over R. This time the R is, if we take the Thevenin resistance, so we have to short this one. So the circuit is the capacitor, the resistor, and the source. So we want to calculate the resistance across the capacitor, the total resistance across the capacitor. So for this we need to use the Thevenin resistance, and in Thevenin what we do, we just short the voltage source. So the resistance will be 4 kilo ohm. There is only one resistance. So the resistance is 4k, and the capacitance value is 0.5 millifarad. So we can say this one, (30 minus 15 e power 0.5 t). This is the voltage across the capacitor, and as we know that this is the equation based on time. So Vc of, we can also write Vc of t. This is the function of time. The capacitor voltage is the function of time, based on time. So let's take an example that, let's say if we put t equal to 1, when we put t equal to 1, we can say Vc of 1 will be 30 minus 15 e power 0.5 into 1, and the voltage across the capacitor will be 20.9 volts after 1 second. If it continues till, let's say if it continues to supply till 4 seconds, then Vc of 1 equal to 30 minus 15 e minus 0.5 into 4 equal to 27.97 volts. So this is the way when we have different sources, so we can calculate the voltage across the capacitor. When we have the capacitor is charging natural response, and we also have the force response, then we have two different responses, so we have to add these responses. Let's take another example. We have one resistor, 10 ohms, 20 ohms. We have the capacitor, we have a switch, and 10 volts. This is 10 volts. The switch will moves up at t is equal to and greater than 0. The capacitor is 0.25 farad. Voltage source is this one. We have 20 ohms. The current is moving I, and 30 volt supply. In some cases, we multiply the voltage source with unit response with unit response. So in the unit response, or you can say unit step function, so we write u of t. This means that when we have this type of multiplication with the function, let's say here, right, we have 30 u of t. U of t is a function which states that the below, we can say u of t is a function which has a value 0 and 1. This has only two values, 0 and 1. T is less than 0 is 0, and t is greater than 0 is 1. So we can say this is a function, and we have, and before 0 this is 0, and after 0 second this becomes okay. Let's draw this one. So we take this one, let's draw it. Let's say this is 0 and this is minus, this is 0, this is t in seconds. So if we say that below 0 is 0, so we have this 0 value, and then it's become 1, this become 1 at t is equals to, t is greater than 0, so just at 0 it becomes 1 and it moves to 1. This is 1. This is u of t amplitude. You can say u of t is amplitude, and this is time. So this is constant. So if we multiply by 30, so after 0 second, it or greater than 0, it becomes 30. If we multiply any number with this, so it becomes that number. If we multiply 60, it becomes 60. If it is 70, it becomes 70. This means that when we multiply with this function, it tells that below 0 means that when the switch is closed, when the switch is, this switch is closed. We am talking about the switch. When the switch is closed, this time the u of t is 0. This means this voltage is 0. This voltage source is 0. So at that time when the voltage source is 0, so we knew that the voltage, initial voltage across this capacitor, VC capacitor, the voltage is 10 volts because it's a parallel connection. So we can say that when we have this type of scenario, so we can say V naught is equals to 10 volts because this is 0. If we have the case that when the switch now when the switch is open, t is greater than 0, the voltage is supplied by this source, and this source is closed. So what is the voltage drop across 20 ohm? Because if we take the what is the voltage across capacitor, will be the capacitor voltage will be the voltage across 20 ohms. So how to solve this scenario? So we call it V infinite voltage. The infinite voltage, the final voltage across the capacitor will be 20 divided by, this is the capacitor voltage, means that the final voltage, or you can say Vs, the new Vs, or we can say Vs, the new one. So 20 divided by 20 plus 10 multiply by the voltage source 30, and it will becomes 20 volts. So we can say the Vs is 20 volts and the new voltage across the capacitor will be 20 volts after the switch is open. So what is the voltage V of t? What is the V of Vc of t? Because we know that this is the, we have to use the force equation because the capacitor is charging. So what is the formula? The formula is, we have voltage source, initial voltage minus the source voltage into E minus T over tau. When we have this scenario, so Vs is 20, V naught is 10 minus 20 E minus T, and the tau, for tau, what is R? To calculate the R, we need to use the Thevenin. So we need to short the supply, we need resistance, we have one resistance here, and we have the capacitor at this point. So we want to calculate the resistance across this A and B, which is the capacitor connected. So the resistance will be the parallel connection of 10 and 20 ohms resistance. So the resistance R will be 20 multiplied by 10 divided by 20 plus 10, and this will be 200 divided by 30, and this one equal to, you can say, 20 by 3 is your R. So we can say 20 by 3 kilo multiply by, we have the capacitor of 0.2 farad. So we can say 20 minus 10 e power minus 0.60 volts, and this is the voltage across the capacitor when it moves from position 0. When the switch is open, this is the equation of the capacitor. Then how the capacitor voltage change. If we want to determine the I, what is the I? Total current passing through this. So we have the current passing through the resistor, current passing through the capacitor, and as we know that capacitor current is C dV by dt, and the current of the resistance will be the voltage across that node divided by the R is equals to I. So we can say the voltage across that node is V. Voltage across that node is 20, and resistance is also 20 plus C is 0.25, C is 0.25, and the equation dV by dt is 20 minus 10 e power minus 0.6 t, so 0.25. So we can say 1 plus, if we take this one, the derivative, we have 0.25, then the power comes out 0.6 minus 0.6, minus 10 remains same, minus 10 e power 0.60 is same. So if we solve this equation, we have 1 plus e power z minus 0.6 t. So to determine the current of this equation I, we need to give I is equals to V over R plus C dV by dt, as the current is entering and these are two leaving currents. So what is the voltage across the resistance? Resistance voltage is the same as VC voltage, the capacitor voltage, and the capacitor voltage is 20 minus 10 e power 0.60 divide by 20. This is the R, 20 ohm resistance, plus C is 0.25 d by dt, and we have 20 minus 10 e power minus 0.6 t. So we can say that this one, we can, if we solve it, this becomes 1 minus 0.5 e minus 0.6 t plus 0.25 into this 20 becomes constant, becomes null and void. This 0.6, when we take this one, this minus 0.6 comes out minus 0.6, and the derivative of t is 1, and if we take this one, this becomes minus 10 e power minus 0.60. When we take an exponential, it becomes the same exponential, and when the power derivative of the power comes in front of this. So we have, this is the equation, and if we solve this value, so we will have 1 plus e minus 0.60. So this is the current equation. So to make it understanding, what is the voltage when time is less than 0, and what is the voltage when time is greater than equal to 0? Similarly, what is the current when time is less than 0, and what is the current when time is greater than 0? So as we know that the before, when the time switch is closed and at the time is less than 0, so the current voltage is 10, and if you want to calculate the current, so if you want to calculate the current of this resistance, will be how much the current flowing through this resistance. Will be, because this voltage source is 0 and this is a short circuit, so the voltage across the node is 10 volts. So 10 ohm divided by 10 is 1 ampere. So we have 1 ampere current. Make it simplification, all the resistance. This is, if this is 10 volts, the complete node will have the 10 volts. So this is why if we have 10 ohm, so the current is flowing from 10 ohm, so this one, the current will be 10 divided by 10, and the current is leaving from plus, so we can have minus 1 ampere. And when we have the voltage across, when the time is greater than 0, so we have 20 minus 10 e minus 0.60, and the current we have 1 plus e power minus 0.60. So this is the equation of the current and the voltage. So we finish our topic of first order RC circuits. We will see you inshallah in the next video. Thank you.